second one we're going to talk about is forces, okay, affecting, okay, rotation. Okay, forces can cause rotation. Now, obviously, if you talk about rotation, this is a topic on moments. Now, how do you know that it's rotating rather than changing speed? The key thing you will see here is this term, pivot. Okay, objects rotate because there's a pivot. A pivot is a fixed point that doesn't move when a force is applied. Okay, the pivot. So the pivot actually determines the way how it rotates and how it rotates because that point doesn't move. Okay, so in this case here, moments. Okay, we're going to talk about moments here. Okay, moments is actually the effect of a force, the turning effect of a force. So how do you know a question is on moments? It's actually by checking out whether there's a pivot and whether an object rotates. Once it rotates, concept, moments. Okay, now, so let's go through a simple question here. Okay, for example, you typically will tend to see a beam with a triangle here. This triangle normally represents your pivot. The pivot point is at this point over here. Okay, then let's say I have a force that's being exerted down. I say this is F1. Okay, so now what's happening is that when you exert a force at this end, this is a fixed point, right? So what happened to my beam? My beam will actually rotate, right, in a clockwise manner. So we say that the F1 produces a clockwise moment. Okay, you can see the first way how I describe moments. Okay, moments has a direction. In this case, the first way is actually clockwise. And obviously, it can also go the other way around. Example, F2. Okay, F2, if let's say now, if I, let's not draw F2 here. Let's draw F2 on a new diagram. Okay, same thing, a pivot. Okay, I have my force exerting downwards here, F2. Okay, F2, you can see here. Now, the force, this is a fixed point. So how will my object rotate? It will rotate in a anti-clockwise manner. So F2 produces a anti-clockwise moment. Okay, now, obviously by knowing the direction of rotation is not good enough. You must know how to calculate the effect. So we talk about moments. Okay, how do we calculate? We say that moments equals to the force. Okay, moment of a force. Okay, moment of a force. Moment of a force is equals to the force multiplied by the perpendicular distance. Let me erase this. Lousy spelling. Perpendicular distance away from the line of motion. Okay, from the pivot to the line of action. Never mind, just take it as perpendicular distance. Okay, so moment of a force equals to force times perpendicular distance. So how do we go about finding this? So example, let's use the same beam example here. Okay, you must always first identify where's the pivot. Okay, so in this case, this is where the pivot is. I have a force downward exerting here. So where's the perpendicular distance? Okay, my force is in this direction, so the perpendicular distance is here. You can see the distance is perpendicular to the force. Let's say the force is maybe 100 newtons. This distance here maybe is 1 meter. Okay, so how do we go about calculating the moments? So the moments is equals to force, which is 100 newton. Okay, please don't write units there. 100 multiplied by 1. So the moments is 100 newton meter. So this is how you can calculate the force. But obviously, if you talk about moments, okay, because it's a vector, you must say the direction. So it's 100 newton meter clockwise. Right, 100 newton meter clockwise. Because as you can see, this force is going downwards and the pivot is here. So the direction moved will be in this direction. It's a clockwise manner. Okay, so this is how you can calculate moments. Now, with regards to moments, okay, this is something you must know. The next one is this thing called the principle of moments. Okay, principle of moments. Now, the principle of moments states that in equilibrium, the sum of clockwise moments about a pivot is the same, or I should say is equal to, is the same or slash equal to the sum of anti-clockwise moment in the same sum of anti-clockwise moment about the same pivot. Okay, in actual fact, what they're trying to say is that when your object, okay, let's say I got the same beam here, okay, I exert a force downwards, I exert another force downwards, F1 and F2. After I exerted the two forces, my object doesn't move, okay, object does not rotate. When it does not rotate, okay, it doesn't move, we say that this object here, it obeys the principle of moments. Okay, if the object here doesn't rotate, we say that it obeys the principle of moments, which means that the sum of clockwise moment equals to sum of anti-clockwise moment. In this case, I only have two forces here, so it makes it very simple, very easy. Now, if I have an object, okay, if I have a beam that looks like this, and I have various forces, maybe I have F1 exerting here, F2 exerting here, F3 here, F4. Okay, so if I say the object doesn't move, it means that it obeys the principle of movement. So I will say using POM, okay, comma, sum of clockwise moment must be equals to sum of anti-clockwise moment. Now, so how do we go about calculating this? Okay, this is how you go about doing it. If I got four different forces here, sum of clockwise moment equals to moments by F1 plus moments by F2. Okay, this makes the clockwise moment, see, clockwise direction. The sum of these two moments must be equal to the moments by F3 plus the moments by F4. Okay, so this is how you can go about doing the principle of moments. Okay, just calculate the moments of each force one by one, then you sum it up. A lot of times people tend to skip steps. So do not skip steps. You know what is a moment. You go and calculate the moment of each force individually, sum them up, and then from there, apply the principle of moments. And you can get your answer. Okay, most of the time it's about using algebra to find it. Okay, so please take note, okay, of this little thing here. Okay, so this marks the end of your moments. Okay, sorry, this is not the end yet. Now, okay, question. If you talk about object obeying the principle of moments, okay, so now, sometimes people ask, oh, so does it mean that every time we got to use the principle of moments to find our answers? Okay, need not always be. Okay, example, I have a beam that goes like this. Okay, I have a downward force here, F1, another downward force F2 over here, another force F3, and F4. Okay, I say that then I can ask you to calculate. Maybe this is the question how it goes. First one, calculate clockwise moment. Okay, calculate sum. of clockwise moment. Okay, they will give you value for F. Okay, maybe this is 50 Newton, maybe 20 Newton, and so forth and so on. They'll also give you the distance from the pivot. Okay, distance from the pivot. So just take note of this. They may ask you calculate sum of clockwise moment, ask you calculate the sum of anti-clockwise moment. Okay, ACW means anti-clockwise moment. Okay, then after they'll ask you, so what will happen to the beam? Okay, now, so what do they mean by what will happen to the beam? If you calculated the clockwise moment and anti-clockwise moment, what you realize when they are not equal, okay, if they are not equal to each other, then this is where you can ask yourself what will happen to the beam. If the clockwise, okay, we talk about if the clockwise moment, clockwise is greater than anti-clockwise, what will happen to my object? It means that object will rotate in clockwise direction. Okay, so if it is anti-clockwise larger than clockwise, then my object will rotate in an anti-clockwise manner. So just take note of this with regards to your moments. Okay, so this is the end for your moments part to try to tackle the questions. I will not go into the part on equilibrium. Okay, you can go and read up on your own.